Welcome to Life in Biology. I'm Dr. Joel Graff, and today we're going to be talking about photosynthesis, but we're going to be tying it into a potential solution to climate change issues. For example, with renewable energy, you have the wind sometimes blows and sometimes doesn't, and the sun sometimes shines and sometimes it doesn't. And so the problem with all that is that you can't get a steady supply of energy. But what we're going to talk about today is storing that energy in carbon, using a carbon neutral solution to address climate change. All right, enough of my intro. Let me just get to the science, so this will make sense in a second. So when we talk about nature's way of doing a carbon storage solution, they use photosynthesis. So this is a chemical reaction. We've got 6 CO2 molecules plus 6 H2O, that's water molecules, go through the process of photosynthesis, and a byproduct of that is 6 oxygen molecules plus 1 6-carbon sugar molecule, glucose typically, but fructose has the same chemical formula. But the thing about I want to focus on the carbon for a second, is that when a carbon has oxygens next to it, it's in the oxidized state, and so it has low energy built up in those bonds. Whereas when you have carbons that are connected to hydrogens through covalent bonds, those are high energy bonds. And so by reducing your CO2 to sugar, you can store energy as a chemical source, okay? Then, when you need energy, whether it's the plant or the animal that eats the plant, you can take those sugar molecules plus oxygen, reverse the process, and end up with water and CO2 as a byproduct. Now, to get the system to go in this direction, you have to have a source of energy, and that is sunlight. And to get the process to go in this direction, for cellular respiration, you are able to release energy during that process. So energy goes in. To get it go that way, energy can come back out. So again, this is our carbon energy storage solution, is sugar. All right, so let's take another look at photosynthesis, just to review that a little bit further. There's 2 main stages of photosynthesis. There are the light reactions, and then there's also the Calvin cycle, which used to be called the dark reactions because it doesn't require sunlight. So in the light reactions, the plants are able to harvest energy from sunlight, and they take the electrons that they strip from the water molecules, and they use those electrons to charge up a molecule called NADP plus to the reduced form of NADPH. Those reduced NADPH have a lot of energy, and that energy gets dropped off into the Calvin cycle. The other thing that happens in the light reactions is an electron transport chain that allows you to power an ATP synthase enzyme, and that is able to take ADP and phosphorylate it with an inorganic phosphate so that you have ATP. ATP has more energy than ADP, and it drops that energy off in the Calvin cycle. Okay, so we got 2 molecules. There's a kind of a intermediate molecules to help transition the energy flow from the sunlight through the reactions over into the Calvin cycle. We start with 6 CO2 molecules, and you have to go around you have to do 6 turns of the Calvin cycle. But as that's going on, this carbon that was originally surrounded with just nothing but oxygen, so the oxidized version, ends up being the reduced version. So that's why I say reduce CO2 until caramelized. So that's the making of sugar. So anyway, then the byproduct of that would be some sugar, a sugar molecule. You get some oxygen coming out of both the light reactions and the dark reactions. Okay, so let's take that and go back to that. What was I talking about? Climate change. The idea would be you have a solar panel or some other source of renewable electricity, and you harvest the energy from sunlight or wind or whatever, and you can create electricity with that. And from that electricity, you could take water molecules and you do electrolysis, which will break up the hydrogens and oxygens apart from each other so that you end up with some hydrogen molecules and some oxygen. The hydrogen could be put into an energy cycle where you use that power to make gas. And so those hydrogens come over here, the oxygen, and the byproduct of the power to gas reaction would be that you could create a methane molecule and a couple oxygen molecules. And then, of course, you could take those oxygen molecules plus the methane molecule, burn it in a natural gas power plant, and create electricity. So the methane would be our solution for storing energy in carbon. And you'll notice the amount of carbon that went in is the same as the amount of carbon that went out, so it's carbon neutral. So this is a way of, rather than using batteries, which would require a lot of mining and probably environmental damage from all the mining, this would be a way of taking CO2 right out of the air, holding some energy in it in the form of the methane version of the molecule of that carbon, and then burning it up later with the oxygen. And so carbon neutral, a way to store energy. We would use natural gas power plants that already exist, and we would be able to have a carbon neutral way of storing all that excess energy when sunlight and wind are prevalent, and you'd save it for when the sun stops shining and the wind stops blowing. So anyway, that was biology-inspired energy solutions. Anyway, I'll talk to you later. Like and subscribe, or not.